Okay, let's go through this module test review, this module 2 test review for the quarter 2 exam. Just going to go through these problems one at a time. So the first section here, we are writing an equation of the line given using the given information. Now your answer should end up in slope-intercept form unless the problem states otherwise. So first one says m equals 2, b equals 1. Pretty straightforward. M is the slope, b is the intercept, and remember we want slope-intercept form, which is y equals mx plus b. So that is just y equals 2x plus 1. And there's your answer there. Number 2 is very similar. It says y-intercept is 5, but the slope is negative 2. Well, just put those in the correct spots. Remember, the y-intercept is your b value, slope is your m value. So y equals negative 2x plus 5. Look at number 3. Now this says slope is 1/2 through the origin, which remember is 0, 0. And if the line goes through 0, 0, that means the y-intercept is also 0. So that's y equals 1/2 x plus 0, or you can just leave it at this, 1/2 x. And you can write the plus 0 if you like. Yeah, it will not be counted wrong if you do that. Okay, number 4, through 5, 2 with a slope of 3/5. Now here we have a point and the slope. So we need to use point-slope form, which again is y minus y1 equals m times x minus x1. And then we'll solve that to put it in slope-intercept form. So that's y minus 2, that's the y value from the point, equals the slope, which is 3/5, times x minus 5, which is the x value from that point. Okay, now we just solve for y. And we do that by distributing here first. So y minus 2 equals 3/5 x minus 3. 5 times 3 is 15, divided by 5 is 3. And then we just add 2 to both sides. So y equals 3/5 x minus 1. And there is your equation in slope-intercept form there. So even though we had to use point slope here, we use that to get slope-intercept form for our final answer. Okay, with 0 slope through 2, -6. Remember, 0 slope is a horizontal line, and that always starts with y equals. And whenever you have a horizontal line, it's y equals, and then you just get the y value from the point. So y equals -6. If you forgot that, you can always just use the point slope process. If you forget that it's y equals -6, you would do y plus 6 equals 0 times x minus 2. And this distributing that 0 gets rid of that whole thing. So y plus 6 equals 0, subtract 6, and you still end up with y equals -6. So whichever way you do it, you still get the right answer here, but easier just to remember with 0 slope, that's going to be y equals, and then whatever the y value is from the point. Now for the next one, the flip side of that, you have to just remember how it works. So undefined slope, that's a vertical line, which means we're going to start with x equals, and then just use the x value from the point, so x equals 2 here for that equation. So if you just remember how those two work, 0 slope, that's y equals, undefined slope is x equals, and then just use the y or x value from the point, those go really fast. You don't really need to do any work on those problems. Okay, moving on. Now number 7 is multi-parts. We're going to use these 2 points to first find the slope, and then we'll write our equation and then change that to standard form. So using the slope formula, which remember is y2 minus y1 over x2 minus x1, we're going to fill in, remember xy like this. So that's 9 minus 5 on the top and 2 minus -3 on the bottom. So that's 4 over 5. Remember, 2 minus -3 turns into 2 plus 3. So 4/5 here for the slope. Now, to write it in slope-intercept form, we don't know the intercept, but we do know 2 points and the slope. So we're just to use one of those points to do point-slope form. I'll use 2, 9, and our slope is, again, 4/5. So point-slope form, that's going to be y minus 9 equals 4/5 times x minus 2. And now we have to solve this one. Okay, so let's distribute that 4/5. So y minus 9 equals 4/5 x minus 8/5. Kind of awkward here, but not too bad really. And now we'll add 9, which to change that to fifths, that would be 45 over 9, or 45/5, sorry. So we end up with y equals 4/5 x plus, and then 45 minus 8 is 37/5. Okay, not the nicest looking equation there, but that's okay. Now we're going to change it to standard form. So remember, standard form is ax plus by equals c, and you need to remember that a must be positive, and you have to have no fractions, just only integers in your problem. So we're going to take this y equals 4/5 x plus 37/5 and move the x term, so minus 4/5 x here, to the other side. Continue this up here. So that's negative 4/5 x plus y equals 37 over 5. And now we need to multiply to get rid of both the fraction and the negative. So we'll multiply by the denominator, which is 5 of those fractions, and then we'll put a negative on it to get rid of that negative sign on the x. So we end up here with positive 4x, right? The negative cancels, the 5's cancel, minus 5y equals, and the 5's are going to cancel here, but not the negative, so negative 37. And there's your equation in standard form. Kind of awkward with the fraction there on the end, but the standard form doesn't look too bad. And you can always check this answer with the points from the first one. If you plug in negative 3 and 5 for x and y here, we get negative 12 minus 25, that is negative 37. And then 2, 9, we get 8 minus 45, that's negative 37 as well. So it does work out. We did get the correct equation there. Okay, moving on. Are the lines parallel, perpendicular, or neither to the line y equals 5x minus 8? Now remember, you're comparing the slopes. So parallel lines have the same slope, and perpendicular have opposite reciprocal, and neither has neither. If it's not the same or opposite reciprocal, then your slope is neither parallel or perpendicular. So for number 8, we have 1/5 here. And if you consider that with the slope of 5, that is the reciprocal, but it is not the opposite. So this is neither parallel nor perpendicular. Looking at number 9, we have to solve for y first. So y equals 5x minus 1/5. And again, we compare the slope right here. 5 is the same as 5, so these are parallel. They have the same slope. And here we have to solve for y again. So minus 10x, negative 2y equals negative 10x plus 8. Divide by negative 2. And y equals 5x minus 4. And again, you want to compare the slopes. The slope here is 5. And 5 and 5, those are the same, so these are parallel lines because they have the same slope. No perpendicular there, just parallel or neither. Okay, number 11, write an equation of a line through 3, negative 6 with a 0 slope. Again, 0 slope, that's going to be y equals, and then use the y value from the point y equals negative 6 And that is it there. Write an equation of a line parallel to the line in A through 5, -2. So parallel again means 0 slope. So again, y equals, use the y value, y equals -2. Okay, write an equation of the line perpendicular to the line in A. So instead of 0 slope, we'll have undefined because perpendicular to horizontal is vertical. So we're going to have x equals, and we'll use the x value here, which is -3. And there you have that section. Okay, solve the system by graphing. We need to just graph these two lines on the coordinate plane there, and then we can find the point where they intersect. So y equals 2x plus 4, we'll do that first. So we're going to start up at 4, and then our slope is 2 over 1. So we'll go up 2 over 1, down to left 1. Okay, and then we can draw the line here, or close enough. The next one is 1/2 x plus 1. So we'll start at 1. Slope is 1/2 or 1 over 2. So up 1, right 2, down 1, left 2, like that. And here's the point where they intersect. That's the solution to the system. It's -2, 0. And there's your solution there, the point where the two lines cross. So just watch out, make sure the slope is correct, and you'll be okay there. Okay, 13, we have to solve these both for y first. So let's do 2x plus 2y equals 6. We're going to subtract 2x. 2y equals -2x plus 6. Divide by 2. And y equals -x plus 3. Let's go ahead and graph that, -x plus 3. We'll start at 3. Slope is -1. So down 1 over 1. I'm going to skip every other because I don't want to draw that many dots. There's the line there, -x plus 3. Okay, let's look at the other one, 5y plus 5x. We're going to subtract 5x. 5y equals -5x plus 15. We'll divide by 5. And y equals -x plus 3 again. So those are the same line, which means they're going to look the same when you graph them, like this. And this means we have infinite solutions. Because those two lines intersect infinitely. They're the same line. So every point on one line will make the other line true. Okay, so that's number 13, infinite solutions. Now 14 is a system of inequalities. So let's first solve this one for y, this first one. So subtract x, -y is less than or equal to -x plus 8. We're going to divide by -1. What that does, remember, is flip the symbol. So x minus 8 is our line there. Let's go ahead and graph it. Greater than or equal to x minus 8. So down 8. And then up 1 over 1 for x. And it's going to have a solid line because of the equal to bar. And it's going to get shaded up above. So just really lightly, I'm going to indicate that. Let's graph the other line. Y is less than -x minus 2. So that starts at -2. Slope is -1. So down 1 right 1, or up 1 left 1. And this one gets a dotted line because it doesn't have the equal to bar. So less than gets a dotted line. And then it is less than, so we shade below. So right here. So we can see the overlapping section is this section right here. That is above the solid line but below the dotted line. And the solution set is the points, or are the points in the shaded area. So we're not asked to here, but if we were asked to name one or more solutions, we would pick points in that shaded region. All right, let's look at number 15. X is greater than 4. We can graph that. Go out to 4 on the x-axis. It's a vertical line and a dotted line. And greater than for x is to the right. So it's going to be over here somewhere. Now the second one we have to solve for y again, so divide by 2. Y is less than or equal to 3x minus 4. So we start down at negative 4. Slope was positive 3 over 1, so up 3 over 1. Down 3, left 1. And that is a solid line because of the equal to bar, and it's less than. So we need to be below that line, but to the right. Well, what we have is probably good enough, but it's just shaded right here, just like that. Below the solid line and to the right of the dotted line. Okay, now we're getting to solving systems with elimination substitution, but first we'll determine whether the given point is a solution of the given system. So what I would do here is just plug in 5 and 2 for x and y. See if it makes it work. You could solve the system too, but this is a little faster. So 3x, that's 15, minus 2y, that's 4. Does that equal 11? Yep. And then negative 5 plus 6 times 2 is 12. Does that equal 7? Yep. So this is a solution. Let's go to the next one. Same idea. 3 for x, negative 6 for y. So we got 3 minus 18, or plus negative 18. Does that equal 15? No. That equals negative 15. So right away we know this is not a solution. There's no reason to do the next one because we don't need to. If it doesn't work for both, it's not a solution to the system. Okay, let's look at 18. Now these are inequalities, but the same idea still works. So put negative 1 in for each x and y here. So negative 1 plus negative 2, so minus 2. Is that less than or equal to 6? That's negative 3. Yep, that is less than or equal to 6. And then we have negative 1, which is positive 1, minus 1. Is that less than 0? No, that is equal to 0, but not less than 0. So this is also not a solution. So that's how I would go about determining those problems. Just plug in x and y and see if it makes the inequality or the equation true, and do that for both in the system. Okay, now solve using any method. Here we go. So for this first one, I'm going to use elimination because we have opposites on the y's. So these will cancel out when we add these together. 3 plus negative 3. 3x plus 2x is 5x. That equals 10. Divide by 5 and x equals 2. There's half the answer already. Then I'll just use this first equation. 3 times 2 plus 3y equals 6. So 6 plus 3y equals 6. We'll subtract 6. 3y equals 0, which means y equals 0 when we divide by 3. So our solution here is the point 2, 0. And again, you should check that just like we did up here. Plug in x and y. So we get 6 plus 0, that does equal 6. And 4 minus 0, that does equal 4. So we know we did it correctly because our solution made both of the equations true. Let's go to number 20. 2x plus 2y equals 6, negative 2x plus y equals negative 2. Now this one you could just as easily do elimination or substitution. I'm going to go ahead and do substitution here. I'm going to add 2x to both sides to solve for y. So y equals 2x minus 2. And now I'm going to take that expression, plug it in right here for y. So 6x plus 2 times 2x minus 2 equals 6. Let's go ahead and distribute. 6x plus 4x minus 4 equals 6. Not only can we combine like terms, we're going to add 4 to both sides there. So we end up with 10x equals 10, which means x equals 1. And then I can plug that in right here. So 2 times 1 minus 2. 2 minus 2 does equal 0. So again, we have 0 for y. 1, 0 for the solution. And just like before, you should check that answer. So 6 plus 0, that does equal 6. And then negative 2 plus 0 does equal -2. So that worked out. Let's go on to 21. Now here, this one just gives you that x equals 3. We can just plug that in right here. Go back to red. So 2 times -3 minus 3y equals 9. So -6 minus 3y equals 9. We'll add 6 to both sides. -3y equals 15. And y equals -5. So our solution is the point -3, -5. We were already given x here, so no need to solve for it. Let's go on to 22. Already set up for substitution, x equals -y minus 5. We'll put that in right here. So -4 times -y minus 5 plus 7y equals -2. Distribute, we get 4y plus 20 plus 7y equals -2. Combine some like terms for 11y. Also subtracting 20, it's going to give us -22. And so when you divide, y equals -2. Then you can plug that in right here. So -2, which is +2, minus 5, x equals -3. So the solution is -3, -2. Okay, let's keep going. Number 23. Again, you could use elimination here, but I'm going to go ahead and just add 6y and use substitution. So x equals -19 plus 6y. And again, if you want to use elimination here, you might multiply both of this bottom equation by -7. And so you could definitely do that if you want to. You should get the same answer as me, regardless of what method you use. So we'll plug this in right here for x. So 7 times -19 plus 6y plus 4y equals 5. So distribute. I believe that's -133, but let's go ahead and just double check that. Yeah, -133 here. So -133 plus 42y plus 4y equals 5. We're going to combine some like terms as well as add that 133 to both sides. So 47y equals 138. And divide by 47. And I believe that's 3. Just to check our math though. 138 divided by, oops, that's not 47. 42 plus 4 is 46. Math is tricky. So we'll do 138 divided by 46, not 47. And that worked out a little better. That is 3. Always good to double check your math. Okay, so y equals 3 here. We're going to plug that in right here for y. So x equals -19 plus 18, which means x equals -1. So the solution here is -1, 3. Moving on to 24. This one's ready to go for elimination. Let's go ahead and add. These cancel here. Also these cancel, so 0 equals, and you get -34. So this is a no solution. If it had been 0 equals 0, if these numbers canceled out as well, that would be infinite solutions, but because they did not, this is no solution. That means these lines are parallel. If we graphed them, it'd be a parallel line with no point of intersection. Let's take a look at 25. Looks like we can use elimination pretty easily here. Let's multiply by -3. So that's -6x plus 9y equals -9. Okay, so if you add these together, these two, everything's going to cancel out. We have 0 equals 0. Here's your infinite solutions example, which I just mentioned. So if everything cancels out, these equations are actually the same, which means if you graph them, they will line up completely. Let's take a look at 26. Yeah, I'd use elimination here as well. We could use substitution, but since it's 2 steps to solve for y, let's go ahead and multiply by -8. So we've got 5x minus 8y equals -17, and negative 24x plus 8y equals -40. Going to add these together, so the y's will cancel, and that's -19x equals -57. So dividing by -19, x is going to equal, and I believe that's 3. Let's go ahead and double check. We do get 3 there. So our x equals 3, let's plug that in right here for x. So 9 minus y equals 5. Subtract the 9. Negative y equals -4, so y equals +4. The solution there, 3, 4. And again, you can always check that by plugging x and y in. I believe this one works out. Let's move on. Now we get to the word problems. So for the systems problems and for the linear model problems, you should try to identify your variables. If it's a system problem, you'll write a system and then solve. This one, however, number 27, is not a system problem. Jenny wants to get a tanning package. The tanning company charges $5 per session plus a membership fee. It costs Jenny $65 to get 10 sessions. So remember, you want to know be able to identify what information that you are given in this problem. What we have is a slope of 5 per session and a point. 10 sessions for $65. That's $10.65. Usually your money is going to be your y value there. So now we can use point slope form to write an equation, then solve to get our linear model in slope intercept form. So y minus 65 equals 5 times x minus 10. And then distributing there, that's 5x minus 50. We'll go ahead and add 65 to both sides, because that's what we're going to have to do to get y by itself. And our linear model is y equals 5x plus 15. Negative 50 plus 65. If the way I wrote that was confusing, remember that's a y minus, you can just bring that y minus 65 down. Might look a little better. Okay, so how much would it cost to tan 25 times? We'll just plug 25 in for x. So 5 times 25 and then plus 15. 5 times 25 is 125. So 125 plus 15 equals $140. So writing a linear model and then using that model to answer a question. Number 28, Allison called the Dancing Feet Studios to find out prices for dance classes. So there is a registration fee, which we do not know. We have 7 lessons is $82 and 11 lessons is $122. Well, what we're given here are 2 points. We have a point at 782 and a point at 11, 122. Okay, so what we can do here is find the slope. So 122 minus 82 over 11 minus 7, that's 40 over 4, which equals 10. So we know the slope is 10. Need to make this a little smaller. Now we can use point slope form with that information. So let's just use that first point. Y minus 82 equals 10 times x minus 7. We're going to distribute there and solve. So y minus 82 equals 10x minus 70. add 82 to both sides, and y equals 10x plus 12. There's your linear model. So how much is the registration fee? That's the B value, that's $12. And how much would it cost for 4 lessons? We'll plug that in for x. 10 times 4 plus 12, that's 40 plus 12, which equals $52. Okay, there's that question there. Let's move on to the systems problems. Okay, here is a systems problem. We have Hannah. She has 47 coins, some quarters and some nickels. The total value of her coins is 535. Find how many quarters and nickels she has. So first we need to write out what our variables stand for. So let's let Q equal the number of quarters, and let's let N equal the number of nickels. So remember our equations here. The first one is just the number of coins. So that's Q plus N equals 47. And for the second one, we will apply the value of each coin to it. So that's 25Q plus 5N equals, and then that's the total amount, 535. We're going to use 535 because we're going to take away all the decimals here. And there's a good system. So we're going to solve this using elimination. Let's multiply that first one by -5. So it's going to be -5Q minus 5N equals, and 47 times 5 is 235, so -235. Add those two equations together. You end up with 20Q equals 300. And when you divide 300 by 20, that's 15. So Q equals 15. So we know that part of our solution is 15 quarters. Now we have to find the number of nickels. Well, we can just plug that into that first equation. So 15 plus N we know is equal to 47. So by subtracting 15, N is going to equal 32. So we have 32 nickels. And there is that problem all done. Let's look at number 30. A rectangle has a perimeter of 18 centimeters. Its length is 5 centimeters greater than its width. Find the dimensions. Well, let's let L equal the length and W the width. Now you could just use X and Y as well. Just don't forget which is which. Okay, so for the equation. So for perimeter, remember, perimeter of a rectangle is the distance around. So if you have 2 lengths and 2 widths, add those all up and you get the perimeter. So for the equation here, that's going to be 2L plus 2W, and that's going to equal 18. And the second equation is right here. The length is 5 centimeters greater than its width. So the length is equal to the width plus 5. And there's your system. So now it's set up really well for substitution. So 2 times L, which is W plus 5, plus 2W equals 18. So that's 2W plus 10 plus 2W equals 18. We'll do some simplifying here. 2W plus 2W is 4W. We'll subtract 10, so 4W equals 8. Divide by 4, and W equals 2. So the width is 2 centimeters. Now we can find the length by using this equation here. So L equals, the width is 2, 2 plus 5. So the length is 7. Don't know why I started to write a 5 there. And the length is 7 centimeters. Okay, we got one more problem to look at. So Nathan is older than Stephen. The difference in their ages is 12 and the sum is 50. Let's find the age of each. So let's let N equal Nathan's age and S stand for Stephen's age. So for the equations, Nathan's older than Stephen and the difference is 12. So that's N minus S equals 12. The sum is 50. That's N plus S equals 50. There's your system. Let's solve it. Now we can see this is set up really well for elimination. So 2 and the s's cancel equals 62. Divide by 2, and we know that Nathan is 31. We can solve for Stephen because we know that 31 then plus Stephen equals 50. The sum of their ages is 50. So subtract 31, and s equals 19. So Stephen is 19. Okay, that is it for this review. Remember, if you have questions on this video, on this review, please let me know. But this is a good overview of Module 2, which is, remember, Quarter 2, for the test we are going to take.